So let's get on with the topic of mergers in Cournot markets, in particular the merger paradox in these markets. So this actually goes back to an idea, to a paper of Simon, Fletcher and Reynolds from 1983, which is basically called the merger paradox. And it analyzes or looks at a model, a Cournot market model, in which there's n symmetric firms. A very easy setting would be one where costs are just symmetric and all linear, so constant marginal cost. In other words, marginal cost is C for each firm. Price is linear, the demand equation is linear. So price is just some A, which is the maximum price achievable in this market, minus the total quantity, so the sum of the individual quantities of each of these n firms. And in that case, we can obviously write down the profits for each firm, which will just be P, the price, minus marginal cost, times the quantity that's produced by firm I in this market. And if we then substitute this the demand equation, you see this this second expression over here. Now, obviously, this is a market that we know very well, so we can compute actually the Nash equilibrium in this, the Cournot equilibrium in this market. We're computing the equivalent quantity, equivalent prices, and therefore also the equilibrium profits. And if you have paid attention in your macroeconomics industrial organization course, you probably know that in this particular market, actually profits have this simple form. It's this cutoff A minus the marginal cost C squared divided by the number of firms plus 1 squared. So in particular for a duopoly, it's 1 over 3 squared in the dependence of the profits, and for a quadrupoly, so with 4 firms, it will be 1 over 5 squared, etc. So let this be the starting point, so these n different firms, and now suppose that a number of firms in this market actually decide to go together, and this homogeneous good market, so to jointly produce and to coordinate basically the total quantity that they produce together. And let's suppose that it's m out of these different n firms, so perhaps 2 firms out of 5, if m is 2 and n equals 5, decide to go together and merge. So what happens if 2 out of 5 firms merge and the other 3 remain independent? We end up with basically with 4 firms, of course, right? And again, these firms are completely symmetric. So we started with 5 independent firms, and we end with 4 symmetric independent firms, and we can of course again see who benefits from that merger. Now, obviously, if you are merging, you will notice that if you reduce your quantities from the before merger setting, you are going to raise price and reduce quantities, but now some of the raising of price or the reduction of quantities, actually you can internalize that, right? So you can internalize the effect that you will have on the firm that you merged with. So there's an additional incentive for these merging firms to actually reduce their total output, as they will internalize these profit effects on each other. So now outsiders who are not merging, so these 5 firms out of which 2 are merging, these remaining 3 firms, they will see, oh, these 2 merged firms are reducing their output. Well, this is a Cournot market. If you are reducing your output, I will respond by increasing my output. Actually, that's how the optimal responses work in Cournot markets, as you know. So outsiders will increase actually their quantities. So what's going to happen? We're going to reach a new Nash equilibrium. So again, this will be a Nash equilibrium in which obviously 4 firms, but these 4 firms again are symmetric. So the new market will just be in this example, the 4-firm market rather than the 5-firm market with 4 symmetric firms. So in general, the n prime, where n prime is the number of firms that remains after the merger has taken place, n prime symmetric firms. So if you want to express this n prime in terms of the initial number n and the number of merged firms m, then it will of course be n minus m plus 1, because you started with n, well, m out of these n firms have merged, and so they vanish from the market, but they are replaced by a single one firm. That's the merged entities. That explains this expression, obviously. So again, it's a symmetric market, symmetric oligopoly. So we can again compute the profits, again the same computation, but now with n prime, the lower n, the new version of the number of firms after merger, popping up there in the denominator. So same profits, which are going to be, this profit per firm is going to be higher because n prime is going to be lower, right? So who's benefiting from this? Well, obviously the outsider firms are benefiting. Total quantity in this market goes down, total price actually goes up, and the profits of each of these individual firms is going up as well. So they're capturing basically part of the market share that was previously captured by these two, or these M in general, merging firms. So these firms benefit from the higher price and from the slightly higher output that they can actually put into the market. So outsiders are very happy about this merger, but what happens with these M merging firms? So they started out with 2/5 of the quintuple, right? The 5 symmetric firm oligopoly profits, and they end up with 1/4 of the quadrupoly. That's a difficult word. Try it out for yourself. So the four firm oligopoly. So which is bigger? Do you prefer to have 2/5 together of this 5 firm oligopoly, or are you happier with having on aggregate with these two starting firms 1/4 of the 4 firm oligopoly? Well, that's a question, right? It's not that straightforward to see this immediately, but we can actually work this out. Here we are working this out actually for an example with 10 firms, starting point of 10 firms. So this green line actually denotes what's the profit before the merger of a number of joint firms that decide to merge. So if 2 firms out of these 10 firms want to merge, they will, initially before the merger, they have 2/10 or 20% of the total sector profits in this 10 firm market. So that will be the corresponding point here on the green line. And if half of these firms decide to merge, or 5 firms, they would basically have half of the total profits. Jointly, they will control half of the total profits in this market, and all 10 firms, of course, will capture 100% of this 10 firm industry profits. So after the merger, these merging firms are being lumped together and are restricting their output as they would, because they are internalizing these competitive effects. So you can again compute, what's their profits now. So if it's just 2 firms that have merged, they will just be together. They will become one of the remaining 9 firms. So this is precisely 1/9 of the 9 firm oligopoly. If, on the other hand, we had 5 firms that merged, then there are 5 remaining firms which have not merged. So in total, there will be 6 remaining firms in the market, and each of these will have 1/6 of the 6 firm oligopoly, which is this point. What you see here is that the total profits of these merging firms is actually below what they had before the merger. So it's only when more than 8 of these 10 firms, so 9 or 10 of these firms, are merging together, so almost reaching a complete monopoly in this market, that the total effect from increased profits per firm outweighs the fact that they're reducing their quantities in response to each other. So only if there's a merger to almost complete monopoly is there incentive for these firms indeed to do the merger. Otherwise, they are sort of better off by remaining competitors, and jointly and their shareholders therefore would have higher profits. So shareholders would not be very happy with such a merger under these conditions if it's going to tear down profits from this high level jointly to this much lower level after the merger. So that's a paradox, right? So if obviously a merger does create market power, but it's not going to benefit these firms that are merging. Of course, it's going to benefit the outside firms. It's going to be detrimental for consumers because prices are going up. But the merging firms themselves actually do not win from this. They typically lose except in exceptional circumstances like over here. So what explains then that we do see mergers in practice even in markets that we would really characterize as oligopolies and as corner markets? So we are missing something here. One thing that we're missing and that we will go and analyze, explore in the remainder of this lecture is, well, typically there's also cost efficiencies. So these cost efficiencies might also drive, or will typically also drive, the desire to merge, and they might actually offset this effect that we just saw in the market in the merger paradox. So that's one effect. So that might mean that after all, these merging parties are better off exposed after doing this merger. Another obvious point to make here is we looked so far at complete homogeneous market with complete corner competition. If we look at price competition, this story will be completely different, and we'll see that story actually in the next lecture. But let's go on and look at cost efficiencies then. So this market power effect that we saw is always going to be bad for welfare, right? So there's always going to be, and the increase in market power will lead to some deadweight loss here. So the straightforward response to that is we don't want to have any mergers because it's only going to be bad for welfare. Now, obviously, if we would do that, we would be overlooking all these potential cost efficiencies that are actually good for welfare. And there is actually an old argument that this trade-off between market power versus cost efficiencies is not that straightforward as you might think. Actually, these cost efficiencies are often or are easily larger than the deadweight losses that we incur as a result of market power. And what Williamson, so the famous Nobel Prize winner on transaction cost theory, particularly the theory of the firm, what he pointed out was, well, you don't need that large efficiencies to actually outweigh these market power effects in terms of total welfare. And the way to capture that argument of Williamson's is basically in the catchphrase, triangles are smaller than rectangles. So what does that mean? So here we see indeed our typical demand curve model, demand supply curve model of an oligopoly. So with full competition, that obviously this black line over here will be the demand curve. So price as a function of quantity. So the upper drawn line here would be the marginal cost, which would be constant. So if there is a full competition here, then obviously the total welfare that's created by this in this market will be the blue and the red areas, right? So that's this big triangle. Now, what happens if there's some market power as a result of a merger? Well, then obviously the total quantities will be going down. So indeed, the total price will be going up, and what you'll see is, well, obviously here the blue area, which is the consumer surplus, is going down as a result, and the red area here would correspond to this deadweight loss, as we've seen before. So this is the triangle in this catchphrase. The triangle is the deadweight loss triangle, the Harburger triangle, if you wish. So that's a loss. But on the other hand, if there's also an efficiency effect, the marginal cost of these firms that are merging might be reduced. So we measure that here in this, or depict that here in this graph, as the new marginal cost line will be a little bit below the old marginal cost line. So this dashed line over here, that will be the lowered marginal cost effect. So that creates, of course, a welfare benefit. Well, what is that benefit? It's this green area, right? So this additional surplus gained here. In terms of produced surplus, yes, that might be so, but this total surplus, right, that we might care about most as economists. So this green area is something that we gain in terms of total welfare. Now, well, which is bigger? Well, in this picture, they are approximately equally big. But if these market power effects are not that large, this red area would be, this red triangle would be smaller. And particularly what you can see is it is going to be, it's a triangle, so it's going to be quadratic in the change in Q, right? So the area of this triangle will be of the order of Q squared, of the change in Q in particular square. That's what the area of a triangle looks like. The area of this green rectangle here, that will be proportional to the total quantity times linearly the change in costs. So typically this red area will be of second order only in the change of Q, the change of quantities, or the change of prices if you wish. This green area here will be first order in the change of costs, and will be multiplied by the total quantity of all the goods that are still produced. So it's easy, in particular for small changes in these in prices and in costs. It's pretty easy actually for this green area, this rectangle here, to be bigger. If we shift this a bit to the right, it will easily be bigger than the red triangle that we see here. So that's basically Williamson's argument. Triangles, in particular for smaller changes in the market, will typically be way smaller than the rectangles that we gain in terms of the cost efficiencies, and only for large changes, say here from full competition to full monopoly, as we might have seen here, the other effect might actually go and outweigh that. So that's the merger paradox, and also the hint that we might want to focus on cost efficiencies, and that's actually what Farrell and Shapiro, the paper that we want to discuss next, and that you can read, or that you perhaps already have read, which on your reading list, that we're going to discuss next. So we'll have a look at cost efficiencies.